Welcome to qnawire.
In this problem, we have a combined gas steam power plant. So we have water in the steam cycle is heated in a well-insulated heat exchanger by the exhaust gases. The exhaust gases enter the heat exchanger at 800 Kelvin and exit at 400 Kelvin. We have a flow rate of gas of 60 kilograms per second. Water enters the heat exchanger at 200 degrees C at 8 megapascals and leaves at 350 degrees C and also 8 megapascals. So what we were looking for, if the exhaust gases are treated as air with constant specific heats at room temperature, the mass flow rate of water through the heat exchanger, we're looking for that. So we can figure out the rate of heat coming out of the exhaust gases because we know the mass flow rate of the gas, and we're told to use a constant heat capacity, and we can probably, assumedly, we'll be given that. And then that would just is the difference in temperature here. So the rate of heat transfer out of the exhaust gases winds up being 24.1 megawatts. And now we know pressures and temperatures at 1 and 2. So we can get the enthalpies at 1 and at 2, right? Again, assuming we given some tables or some information to get those. And so what we know then is the heat out, the flow of heat out of the gas must be the flow of heat into the steam or into the water because the heat exchanger is well insulated. So this is just an energy balance. The flow into the heat exchanger must be the flow out of the heat exchanger. The energy flow anyway. So then this is the energy increase in the steam in the water going from this enthalpy to this enthalpy. And so we know everything here, H except for m dot s, and so we can just solve for that, and that winds up being 11.3 kilograms per second, which is answer A.